Welcome back to the deep dive. You know, our mission here is always about taking these, well, massive stacks of complex tech info and boiling them down into what you actually need to know right now.
Exactly. And today, we're digging into something really core to modern IT. We've got the practice materials for the HCIP-Collaboration v4.0 certification. Now, look, this isn't about cramming for an exam.
No, not at all.
It's about using this very specific, very technical knowledge base as, well, a kind of shortcut. A shortcut to understanding the real backbone of how good remote work actually happens and how modern IT infrastructure scales up.
Yeah, we're pulling out the essentials on unified communication protocols, so like, you know, what makes voice and video work smoothly or not smoothly, and connecting that directly to how advanced hybrid cloud systems like Azure Stack, HCI, and HPE are actually built. What this means for, say, the IT manager or maybe an executive is basically, how do we kill the lag? And how do we make sure our tech can actually grow with the business without, you know, falling over?
Precisely. This knowledge, it really represents the intricate plumbing that makes all this high-demand, real-time collaboration even possible. It's fundamentally the difference between a team meeting that just flows globally and one where you spend half the time yelling, "Can you hear me now?"
Right. Okay, let's start with that collaboration layer then. We hear unified communication, UC, thrown around constantly. Our source material really stressed the advantage of, well, fully integrating these UC platforms. What's the biggest win there for the actual user?
It's fundamentally about getting rid of that constant context switching. You know, when you properly integrate video conferencing with your main corporate tools, your calendar, email, shared files, that kind of thing, the user can suddenly manage everything, meetings, invites, the documents you share, all from that one single interface. The efficiency boost is huge because you stop needing to juggle like 5 or 6 different apps just for one call.
That makes perfect sense. Less friction, more getting things done. Okay, now let's get into the actual experience, keeping that video quality decent in real time. The sources went pretty deep on frame rates. What's the key thing to grasp about how frame rate affects what we see?
Frame rate is just fundamental for visual clarity. We've all experienced bad low frame rate video, right? That looks choppy, maybe blurred, kind of jerky.
Oh, yeah.
Especially if there's fast movement on screen, like someone waving their hands or pinning the camera. Boosting that frame rate smooths everything out. And look, it's not just aesthetics. It's vital for clear communication when you need to actually see what's happening properly.
And running underneath that video stream, you've got this critical pair, RTP and RTCP. Now, RTP, that carries the actual media, the voice, and video packets. But RTCP, the real-time control protocol, you called it the unsung hero. What's its actual job?
Think of RTCP as the quality control inspector sending reports back up the line. It doesn't carry the video or audio itself. Instead, it reports on how the transmission is going. It sends back metrics, like packet loss data that just vanished, or jitter, which is that really annoying inconsistency in when packets arrive, and overall delay, too.
And why is getting that feedback so crucial?
Because it's what keeps everything synchronized. If your audio and video start drifting apart, which happens all the time on less than perfect networks.
Right, the lip sync issue.
Exactly. RTCP flags that. And that allows the systems at either end to dynamically adjust things. Maybe they dial back the bandwidth a bit or switch to a different codec, basically. Do whatever's needed to keep audio and video locked together and the call, well, usable. Without that constant feedback, things can fall apart really fast.
Okay, so that's quality control. Now let's shift to the setup, the digital handshake, the signaling protocols that actually establish the call. Let's talk SIP, Session Initiation Protocol. If I send out a SIP invite, what's the definitive signal I get back that says, yep, we're good to go?
That signal is the 200 OK response. It's pretty much the universal thumbs up in the SIP world. It means your request was understood, it was successful, the other end is ready. Let the conversation begin.
And in a big company, you could have thousands of calls happening at once. How does CP make sure my 200 OK comes back to my specific call attempt and not someone else's?
That's where the SIP call ID header comes in. Every single SIP session or dialogue gets a unique identifier stamped into that header. It's absolutely essential for making sure all the follow-up messages, the responses, everything gets routed to the right place for that specific call.
So it's like a unique tracking number for each conversation.
Precisely. And it ensures when the call finishes, the session is torn down cleanly too.
Okay, now we have to touch on the older standard, H323. Why is this architecture still relevant, still showing up in these modern certifications? And critically, how does it manage to work with newer SIP networks?
Well, H323 is still out there.
Yeah.
especially in some established, maybe older video conferencing setups globally. So you need to understand it for interoperability. The key control part is the H.225.0 RAS protocol, right? Registration, admission, and status. It handles things like device registration, controlling access, status updates, all managed through something called the gatekeeper. You can kind of think of the gatekeeper as the bouncer for these older H.323 video systems.
Okay, the gatekeeper decides who gets in.
Exactly. It makes sure only authorized registered devices can join the network.
And then how do you bridge that H.323 world to, say, modern SIP phones or even the regular phone network, the PSTN?
For that, you need a dedicated H.323 gateway. Its whole purpose in life is protocol translation and format conversion. It's the interpreter.
Ah, the translator.
Yeah, it lets H.323 devices talk smoothly to SIP endpoints or connect calls out to the normal phone system. Without that kind of gateway, you'd have incompatible islands of technology, which is just a nightmare for businesses.
Yep.
Interoperability saves massive headaches and expense.
It's incredible, really, the layers of complexity just to get two people talking clearly. But then you scale that up to a big group meeting, and things get even more complex. Which brings us to the multi-point control unit, the MCU. What's its basic job, its kind of directorial role?
The MCU is essentially the brain, you could say, or maybe the central processing hub for these big centralized video conferences. It's the meetings director. It takes in all the video and audio streams from all the participants.
Okay.
And its job is to mix those streams together, manage the screen layouts, who sees what, and make sure the right audio feed goes to the right people.
So it's managing the whole visual and auditory flow of the meeting. What are some of the more advanced things an MCU can do that really make a difference in, I don't know, a 50-person remote meeting?
Well, managing that visual flow is key, like you said.
Yeah.
For example, a common feature is automatically switching the main video window to whoever's currently speaking.
Oh, right. Active speaker switching.
Exactly. That sounds simple, but it keeps everyone focused and stops that sort of confusing visual noise. But beyond that, administrators can often define custom layouts. So for a really important board meeting, maybe you could ensure the key people are always visible, regardless of who's talking. It really improves the organization and, frankly, the engagement in complex discussions.
Okay, so the MCU makes the meeting itself feel organized and professional.
No.
But to keep that MCU, the director, running smoothly, especially under heavy load, you need good central management, right? What key metrics did the material say admins need to watch?
Yeah, absolutely. Centralized management using tools like Huawei's SMC or other network management systems, NMS, it's not optional, really. They constantly monitor three main things: bandwidth consumption, the actual CPU load on the MCUs and endpoints themselves,
Right.
and just the general health or status of all of the devices. If an MCU's processor starts hitting 90%, or if network bandwidth drops unexpectedly, the monitoring system flags it. That lets admins jump in before the call quality tanks into lag and dropped connections. It's like predictive maintenance, but for collaboration.
That makes sense. It's amazing how much heavy lifting that MCU does behind the scenes.
Given how vital it is for these different standards, like we talked about H.323 and SIP, to work together, how might future network management tools evolve? Could they offer truly seamless, proactive monitoring across these different protocols without needing all these separate gateways and manual configs? Could they dynamically adjust quality across boundaries?
That is a fascinating question to chew on, especially as these enterprise networks just keep getting more complex. Definitely something for you, our listeners, to think about. Thanks for diving deep with us today.
Yeah, thanks, everyone.
We'll catch you on the next one.